This is the repo that we've been using. Today we will be visiting, this is part 2. We'll talk about NSMutableArray, NSDictionary, NSMutableDictionary. We'll start talking about Objective-C methods, and we'll talk about properties, and we'll end out talking about initializers and inheritance, okay? So that gives us a lot of stuff to do this morning. So let's continue on. All right, let us kick it off with, let me make sure I'm following this so I don't skip over anything. Let's go ahead and actually just let's remove this. We'll come back to this here. So remove the person Eric. We'll come back to this later. And let's go into NS, what do we say? Mutable array. So we saw what NS array was earlier, but if I want to mutate it, like add more objects to it, like right now, if I say programming, if I want to add more programming languages here, if I say programming languages, add, there's no add object, right? I want to be able to add more languages to this particular array. So that doesn't work on an NS array. Let's just create a new array to show what NSMutableArray looks like. So we'll start off by saying NSMutableArray. Again, it's an object. All objects live on the heap. You need to have that pointer here to specify that it's an object. So here we will call this array race types. So far, so good. We will go ahead and allocate memory for it by saying NSMutableArray alloc, right? So allocating memory for it. And then we'll just initialize it. In this case, we'll initialize it without anything. Other initializers I could initialize it with a given array, like our programming stacks, for example. I could pass this array in here. I could initialize it with objects. Okay, so but for now, we'll just initialize it as an empty array. Think of it like if in Swift you could do something like var race types equal to some empty array of some type string, right? Think of it like that. This is what we are doing here, okay? Very same thing. Just a bit more square brackets, right? Semicolons, pointers, right? Cool. And also specifying the type. So that's why, again, Swift is so beautiful. All right, let's continue on. So now we want to add items to this array. How do we add items to this array? So remember last week when we spoke about method calls? So if I want to call a method, like in our Swift, we could say race types. We could say race types dot append, right? And then we just put in whatever we want to put in here, like marathon, for example. And I'm done. So this is how I call a function or a method in Swift. In Objective-C, I specify the instance. In that case, my instance is race types. That's my instance. I want to call an instance method on race types, right? I specify the name of the function now. So I say space. There's no dot, right? So this is not going to work, like dot add, right? That would be awesome, but that's not how we do it in Objective-C. Square bracket, instance name, space, and the method name. In that case, we are looking for add object, right? And here it's expecting some type ID. We're not getting to ID for now, but think of ID as any object, right? I could put in anything here. In our case, we want to put in strings, right? So we'll say at some string, right? So this is perfectly fine here. This is legal. Of course, we'll give it a name, but this is what it is. The instance type and the method name. And the method, in that case, that method expects some sort of argument, some sort of type. It could be any type here. Our type, we'll say we'll add marathon here. And we'll copy, actually, let's not copy this. Again, we're learning. So just do race types again, add object, some object here. I'll just say 10K. Don't forget your semicolon. We'll add 2 more race types, add object. Here, I'll say half marathon. And And lastly, we'll just say race types, add object. And here I will say triathlon. Okay, cool, awesome. So here we have 4 objects in an array. And I want to go ahead and print out what that array looks like. So I will say for what's required here, anybody? How do I write that follow? Walk me through it. Any volunteers?
Do you need a pointer?
We need a pointer, but we'll start with our for loop, right? We'll say for.
Oh, would it be NS string, like in parentheses?
Yes, very good. So it will be NS string in parentheses. Very good. So here I'll say NS string. Now I'll say pointer, Eric. Thank you for that. And we'll just say race here, or race type in race types, right? Cool. So at this point, we are perfectly fine. We are legal here. We specify what type it is. We said there are strings. And again, I won't get into that right now, but you could easily have mixed objects in here, like numbers, Boolean values, right? But here we are trying to code everything saying it's a string. So we know we guaranteed to have a string here. But it's easily that you probably don't have a string here because you have mixed objects. And then that's where the type ID will come in, but we won't get into it today. But for now, we just have all the same types. We have NS strings. And now I will just NS log, and I'll say race type is, and the placeholder race type. What's the format specifier am I going to put here?
The percent at.
Percent at, very good. So now if we run our code, let me move myself here. Right now, if we run our code, we'll see race type is triathlon. Everybody got this? Race type is marathon, race type is 10K, half marathon, triathlon. We all got the prints happening?
Yep.
All right, awesome. Let's take a look at, let's continue on. So we just did NS Mutable Array. Let's go into NSDictionary. And we'll create a dictionary here of places. Okay, cool. So let's create our NSDictionary. We'll call it places. And let's see what the syntax looks like for this. So it starts with an @ symbol again. So we've seen our string starts with an @ symbol. We've seen our array starts with an @ symbol. And now we'll see our dictionary starts with an @ symbol. But to make it even a bit crazier, we have curly bracket here. Okay, and our semicolon. All right, so here we have a perfectly fine dictionary. It's empty, but we'll put things in here. Now, again, in Swift, we do the same thing. We have var. Actually, that would be a constant, right? Var places, and then we'll have some sort of dictionary. Not really useful because it's empty and it's a constant, right? But you want to put values in here. If we have to put values in here, we could say New York, and the place is Brooklyn. Let's just call this places dict here. New York, Brooklyn, and then if we have a next key value pair, we could say something like Sweden, and we have Malmö. Right, so that's Swift, right? So I have a dictionary ready to go, like that. In Objective-C, if we want to do the same thing, what does it look like? Well, we have strings and we have strings, right? So we know what a string looks like. So we'll start off by saying at string literal colon at string literal, right? And in the string, the first string here is the key, right? So key value pair, in our case here, sorry. In our case here, we'll say New York, and we'll say Brooklyn. We'll add a few more. Let's go ahead and add Sweden, Malmö. Cool. So here we have our dictionary. Awesome. Let's go ahead and iterate through it. Let's iterate through it down here. So we'll say for. Again, the parens is required, right? We'll say NSString. We'll call it place, in, place is dict, right? So we're going through each of those values here. And now we want to print out the value. So we'll say NSString first to get the value. The value is a string. We'll call it place value. And how do you access? How do you access the value, right? How do you use the key to access the value? Well, thankfully, it's very similar to Swift here. Let me just call this place key so it's easier to understand. Place key and place value. So if I want to access the value for place key, I'll say place key. Actually, don't call this place key. That's is that fine? Yeah, that's fine. Place key is fine. Yeah. To access this, I'll say place is dict, and then put the place key in here. And my semicolon. So this is very similar to Swift, right? You have your dictionary and you access a key. So this is very familiar. And now I could print out the value. So I'll say NSLog. I'll say the place key is whatever the key is here. And the value is whatever the value is here. So here we have two placeholders, right? Again, last week, I think Ben was asking this question. You could have many placeholders. You just have to provide them here after the comma, right? So our key is place key. And our value is place value. And don't forget our semicolon here. And build. And let's go ahead and run it. And here we have the place key is Sweden and the value is Malmö. And here we have the place key is New York and the value is Brooklyn. Was everybody able to get that printed out correctly? Just looking for one acknowledgement, if possible.
Yes.
All right, awesome, cool. So this is NSDictionary. Let's go down to talk about NSMutableDictionary, right? How do I mutate? How do I add more things to some dictionary that I created? So here we'll say NSMutableDictionary here. And what are we going to create here? Let us create a different dictionary called NSMutableDictionary. And this one will just be called platform. And we will go ahead and allocate memory for it. NSMutableDictionary. And we'll just initialize it as empty. And now we could mutate. So the two differences are, again, between the NS, whatever the object is, and the NSMutable. The mutable allows you to modify. If you want to modify, you go with mutable type. If you want to just keep it constant, you stick with NSDictionary. Cool, awesome. So here, let's go ahead and just add some platform. Platform, we'll say set object, right? So platform set object here. And again, the object could be anything. And the key, in our case here, we'll make it a string. So we'll say iOS. What can I do with iOS? Well, if I know iOS, hopefully I could also do iOS apps, right? Cool. And let's add one more. I'll just copy this and say set object. If I know Java, chances are I also know how to create Android apps. Cool. So there we go. We could add more things to it. And let's go ahead and let's see, platform. Let's count how many objects we have here. NS log and say currently we have some object here. Currently we have 2 stacks. And we want to count it. So how do we count? We will call platform.count and we'll put our semicolon. Let me build here. We need to change our specifier here to, let's just use the fix it button here. Let me back up here for a second. So here we want to count something. If I want to count something, the specifier is not the @ symbol, it's LU. LU is basically a long integer. So here, just let the compiler take care of it for you for now. And once you're done, run your code, and we should hopefully see 2 objects here. Currently, we have 2 stacks, right? So here we are. Currently, we have 2 stacks. So this is how you count your dictionary objects. All right, let us keep going. Let's go into Objective-C methods and get some more coding done here. So Objective-C methods. Again, there's a difference between Objective-C methods and C-style methods. So we're currently in a C method, right? If I scroll all the way up to where it says int main, this is not Objective-C. This is a C method, okay? This here is not Objective-C. This here is a C method, or C function rather, okay? All right. Again, Objective-C is coming from C, Swift, C, Java, C, all languages is really coming from C as far as C-style languages go. But here we want to go into Objective-C territory. So now we'll go say, let's go create an Objective-C method. And then here we'll have class methods, and instance methods. Cool. Any questions so far? We've done a lot of code this morning. Any questions? Okay, let's continue on. Class methods and instance methods. So last week, I think we ended out talking about methods, right? We took a quick look at info. If you go to your person.h file, we created some method called info here. And we also implemented it. We implemented it here. Let's actually just redo all this so we get a second look at it. So delete everything from your implementation file. So inside of the implementation, the person.m, just delete everything and go to the person.h and also delete everything here. Okay, so your person.h and your person.m should just have the stubs and no functions in there. So we'll go ahead and we'll recreate those functions from scratch. And if you build and you have an error, that means in your main function, you probably still have the person allocated there. Just remove it. Cool. All right, so let's go back to the main function. And right now we are talking about Objective-C methods, class methods, and instance methods. So we want to take a look at both of them. So first, let's go ahead and create an instance method on our person object. So click on person.h. Again, in Objective-C, as opposed to Swift, if somebody was to tell you to create an object called person in Swift, right? You would do something like this. You would create some sort of object struct person, right? How many files are we creating here? One file. Yes?
Yes.
All right, cool. In Objective-C, same question. Somebody tell you to create an object called person. Here you have to create two files, right? And the two files would be person.h and person.m. Okay. Person.h holds I'll say the definition, or declares the methods, right? And person.h or person.m, sorry, implements the methods, right? So person.h doesn't implement anything. Person.h is where you declare, I will have some method called info. I'll have some method called init with name, right? And in the implementation file, in the .m, that's where you implement the body, right? That's where you put your curly bracket, and inside the body, that's where you implement your function. So let's go ahead and create a info function, an instance function. And again, instance functions are called on the instance of the object. So instance methods, and that applies to both Objective-C and Swift and Java and any other language that you're dealing with. There's instance methods and there's class methods, right? Instance methods are called on instances of an object, right? Class methods are called on the class itself. Again, very valid interview question, right? So know those things. Doesn't matter Objective-C or C, or doesn't matter Objective-C or Swift, right? So let's go create an instance method on person.h. So here, let's just add methods here. I'm in the person.h file. And I will create, again, instance method starts with a minus in Objective-C. The minute I start with a minus, I'm saying I'm declaring an instance method. I have my open parens. I put my return type. In that case, our void, our info won't return anything. So here I'm specifying. So this is close to C, right? Like in the C function we spoke about earlier. But so far, what's the difference? You have your minus and you have this parens here. And now you'll give it a name. So I'll call it info, like that. So that's it. That's all that goes here in the header file. There's no body here, like this, right? The compiler is gonna start yelling at us, right? This is not what we're doing here. All what we're doing here is saying I will have some method called info. And this method is an instance method. Okay? An instance method because it has that minus here, and we'll be calling it on an instance. So this is our info. Now let's go to our .m file. Most times it's probably just easier just to copy this, right? Just copy your method name, or you could just type it out, doesn't really matter. Now let's go to our .m. In our .m, which is empty right now, we could just type in info, it will show up, so we don't have to copy it. And there we are. And we put our open curly and our close curly. If I build at this point, I should not have any errors, right? Because all that is compilable code. I declared my method, and now I implemented my method. So far, it doesn't do anything. 1 second. What's happening? So far, it doesn't do anything, right? But we'll make it do something. We'll say nslog. And like we did last week, we'll simply say this is a person. Full stop. right? Any questions so far?
No, we're good.
So let's go to our main.m. In our main.m, I want to now create an instance of my person object. Do we have an instance yet? No, we don't. We just removed it, right? So let's create an instance, because again, instances work. Instance method works on the instance. Let's create an instance of person, right? So person, let us just say person is person. That's fine. And we will allocate memory for this person. And we will initialize. If I say init, there's only one initializer, which is the default initializer. So at this point, we have a person. We've successfully created a person. We first said on the person class, allocate memory for this person, return me some memory address, and initialize this object for me. So the minute I have this object, it's ready to be used. So next step, I want to call my method. So I will say, how do I call a method? Mr. Ben, how do I call a method? How do I call info?
You call it on the instance of the person, or the
Syntax?
name of it.
What's
So
the
in
syntax for it?
You just use the square bracket and then you call the name of the instance and then the
Info.
method.
Awesome. Thank you, sir. So this is it, right? Instance name and the method you're trying to call. In our case, it's info. Again, this is not Objective-C would look like, oh, Objective-C. Swift would look like person.info. Like that, right? Right? So that's what it would look like. So now let's go ahead and run our code, Command R, and we will see our last line says, this is a person. So that was successfully done, right? We were able to call our function. Great. Let's actually, let's see, since we're here, let's
I have a question.
Yeah, go ahead, go for it.
So is the syntax the same with the class method?
For calling the method, yes.
Oh, okay.
Yeah, for calling the method, yes. So it would be uppercase person. We will create one very shortly. The syntax will be the same. But in that case here, it's not going to compile, right? Because this is not a class method.
Mm-hmm.
Make sense? No known
Yep.
class method for selector info. Awesome. Let me see. I don't want to skip necessarily. We have our... Okay, we have to go into properties now, which is fine. Okay, cool. So now let's go. We still in Objective-C methods and Objective-C methods, but now let's go into properties, right? Properties on an object, and then we'll be able to create a class method on that. All right, cool. I think that's good. All right, so let's go to our person.h. I'll just put properties here somewhere. Let's put properties right here, because this is the next topic we will talk about. So go to person.h, and we have our methods. For convention purposes, I'll keep my properties up here. Our methods here, and any initializers we have, we'll put them here. Initializers. All right, we want to create a property. Cool. To create a property, again, in Swift, you have a property on an object. You just say like let name, NS, let name string, right? That's how you have a property on Swift. In Objective-C, to create a property, you use the @ symbol, the word property or the keyword property. In our case, we want to create a string name. So we'll say NSString. It's a pointer. It's an object, rather. So I need my asterisk here, and I will just call it name, just like that. And build, you should have no errors. So make sure you're in the interface, make sure you're in the header file, and we're creating a property on the person called name. There's more about properties, but we won't get into it today. But for now, we're just creating the basic property called name for this person. Now, let's go ahead and create a class method. All right, cool. So right here, we in methods, we have our instance methods, class methods come first. It's not gonna have a compiler error or anything, but convention, class methods come first. So class methods, if you have any class methods, put them first before your instance methods. In our case, we'll create a class method, and our class method, what do we want it to do? Well, we want our class method to basically give us an array of people. So we'll create a class method. Anybody remember what the class method begins with?
A plus. Also have another question.
Yeah, go ahead.
Wait, so in Objective-C, whenever you create a type, an object, you don't have to specify the type of the object. Like you just say, hey, this is my object, and then anything inside that object could just have class or instance methods, correct?
Yes, exactly. When you create it, there's no struct or class. You just create the object. And then once you create your header file, there's no like class, whatever. It's an interface and an implementation block.
Okay.
But they're classes by default. All those things are classes by default. Like person is a class. You with me?
Yeah.
Everything is a class here. Person inherits from NSObject. NSObject is the umbrella class of all objects in Objective-C.
Okay.
All right, cool. So structs are not first-class citizens like they're in Swift. Like in Swift, structs are first-class citizens. You could have functions in them. You could have initializers, But structs are very simple types in Objective-C. Like you could create a struct of a point where it's at X and Y, and that's basically it.
Yeah.
So structs became more useful in Swift, right? Like first-class citizens, you could do same things you could do in classes with structs. All right, cool. Good question. So here we'll say plus, and we will say, what do we want this to return? We want this to return an NS array. And we will call it all people. Okay. So that's what it looks like. It just returns us, again, this method here didn't return anything, but this method here, it's a class method. Class method normally returns some sort of object. Like when you create the alloc method, it returns you some memory or memory address. Here we want this to return us an array of objects, right? Now we want to go ahead and implement it, right? Again, now you're in your header file, but you want to go to your implementation file to implement our all people. Again, try to keep your class methods above your instance methods. So class methods, and here we'll have instance methods. Cool. So here, again, the compiler is complaining here because we're not returning a value yet. We specify we're going to return something here, but we haven't returned anything. So let's go ahead and create some people or person objects. So we'll say person, let's say Alex here, just to keep consistent with our lesson plan. And we'll say we'll allocate memory for that person, we'll initialize some person, okay? Next, we'll create a next object. Let's create Mr. BN here. Open person, allocate memory, initialize object. So here we have two people. Next up, let us add those people to an array. Actually, let's give them names. So we'll say Alex.name equal to string Alex, right? Like that. And we will say same thing for Bien. We'll say Bien.name. And that name is coming from our property, right? So far we have only one property here, that name. And this person will be Bien. This. Cool. And now we want to create some sort of array for those objects. We'll say NS array. We'll call it people. And we'll say, we'll create a literal array. right? So there's no need to allocate and do all that because that's NSMutable. With NSArray, you could just create your literal array and we'll return people like that. So in our array here, we'll say Alex and we'll say Bien. Cool. So this is our method. It's pretty much done. It's ready to use. And we'll call that class method in our main.m. Okay. Any questions yet so far?
Yeah, so you see where we implemented the all people function and the type, the return type. What's that asterisk
It's
next
an
to?
object. It's saying all people is a pointer to some sort of array.
Oh, okay.
In our case here, it's more specifically, we have a function called all people that returns an array. And that array has to be marked with a object syntax or the asterisk syntax here.
Okay.
Right. Sounds good?
Yes. So what's the other types of syntax? Like what other characters are associated, like or types next to the NS array, for example, or objects?
Basically, for our purposes now, there's more we could get into, like pointer arithmetic and stuff like that, but that's a different topic. But for now, if we're creating a simple function just to return some object, this is what you'll come across all the time.
Oh, okay.
If it's if you're just returning, like if I want to create some sort of if I want to create something that returns, what do you want to return? If you want to return an int, an int is not an object, right? And date is an object. Date is an object. Int is not an object. Int is a primitive type. So I could say add, for example, right? Just return 0.
Ah, I see.
Right. If it's an object, you need to have the asterisk. If it's a primitive type, no. You with me so far?
Yes.
Right, very good. Where are we here? So let's go ahead and use our all people. So in our main function, let's go properties. We did properties before, but let's just print out a property and then we'll go to what's class method. Class method is here. But for properties, let's just do, actually, what are we gonna do here? Oh, that's fine. Let's give this person a name. Yeah, let's give this person a name here. So person.name equal to John. And we could print NSLog. We could say the person's name is @ symbol here, and we'll say person name. And here we should get John Appleseed because we just gave this person a name, right? That person started off without a name, right? We assigned a name because now this object has properties and we're able to print it out. Awesome. So now let's go and test out our class method here. So we have a class method. It returns us an array of objects. So we could actually say NSArray here. We could call it people here. And we could say, how am I going to call my class method, Mr. Bien? Our all people array, our all people method. Mr. Searing, how do I call my class method?
Oh, wait. Never mind.
Person.allPeople, no?
Person, like this? What's the syntax for it?
So wait, we're just calling the...
Yeah, we're just calling the function, the one we just wrote.
Maybe person.allPeople.
So lowercase person?
Yeah.
So remember, it's a class method, right?
So capital person.allPeople.
Yeah, so open square bracket, person all people, semicolon, right? Class methods call on the actual class. An instance method is called on an instance of that class. And now we have our array of people. What can we do with that? We could print how many people we have. We could iterate through the people. Let's just actually iterate through people and print the names. So let's do for, we have any strings here, right? Actually, we have people. Let's do person, asterisk, person, in people, like that, and say NSlog. And here we'll say, we had the person name there already, that's fine. We'll just say person's name is, and here we'll say person.name. How many people do we have here? We had 3 people or so, right? We could actually say again, here we could say NSlog, like how many people are we? How many people do we have currently, right? There are X amount of people. Here I will say people.count. Specify is wrong here, just to fix it for now. Okay, cool. So there are, I think we had 2 people, I can't remember, but that's fine. So let's run it and verify all that stuff. So the person's name is Alex, and then there are 2 people right here, right? The person's name is Alex, and the person's name is Bien. So there were 2 people, and those were the people. Cool. We could actually, since we're talking about arrays and all that stuff here, we could say, let me get the first person, right? Let me do that. I'm doing Swift with Objective-C now, sorry. I want to get the first person. The first person is a person. So just do NS, not NS, do person. We could say first person. How do I get access to that first person? Anybody want to tell me how I could get access to the first person in our array? Don't get intimidated if it's as is Objective-C. The syntax is very similar.
Is there a first type on arrays in Objective-C or not?
Let's see, right? So we have our people array, and is there a first, right? There's a first object.
Okay.
Right? And then we could also do index, like this. So here, I will just print out, let's just NSlog and say the first person is at this, and say first person dot name. And here we should get Alex. First person is Alex. Awesome. Great. Moving along. We are doing good. Any questions so far?
How would you like write optionals in Objective-C, or like you don't?
Oh, optionals in Objective-C. Optionals is something that got introduced in Swift. So in Objective-C, if you want to see if something is nil, you have to do like if person equal to nil, something like that. But there's no optional.
Okay, I was just asking because they may or may not be a person in like 0 index if it's empty.
Oh, you could check for count, right? Yeah.
Yeah.
So you could do something like if you want to access this object here, I could do if people that count. I think it's, let me put all my syntax correct so the compiler helps me here. So if people that count is greater than whatever, 0, right? Then you could put this in here. Good question, by the way, because you don't want your thing to crash it, then nobody, right? Then copy this, put it in here, and run the code again. And here the first person is Alex because we have people. But if we didn't have anybody here, like if we say people, I could just set it to nil. And run that again. I won't get any objects here because right now person count is nil, is empty. You with me?
Yeah.
All right, very good question, very good question. Cool. So let me put our people back and run the code again, make sure we have our people here, person object. Okay, cool, awesome. Now, let's keep going. We spoke about properties. We have 2 other topics, and then we will come to a close of the second part of Objective-C. We'll talk about initializers, right? Because a valid question is something like, if we go back to our person.m, a valid question is like, why do we have to create somebody without a name and then go back and put a name for them, right? It's easy to forget to add a name for that person. Is that fair?
Wait,
Yes.
say that again.
Right now we're doing work, unnecessary work kind of, right? Like we initialize a person and then we go set the name. Like, couldn't there be a better way to do both at the same time?
Yes.
You know, so that takes us into initializers, right? So initializers will allow us to initialize some person with a name. Because in Swift, we do the same thing, right? We have an initializer, and when we initialize a person with a name or whatever it is. So let's do that. Let's do that. Let's optimize that code a little bit. So that'll take us into initializers. So go back to main, so we're not losing ourselves here. Let's just put initializers. And let's go create an initializer on person and see what that looks like. So I'll create my initializer right above my methods, like we do in Swift as well. And here my initializer will start off with a minus sign, and it will say instance type. Instance type, like some type. I'm creating an instance of some type. I don't know what type it is, but that's the syntax for initializers here. I'm creating an instance of some type. All right, so my function would be something like init with name. This is very conventional Objective-C. Like your initializer starts with init, and then you say what the first object is. If you init with address, for example, if the first thing is the address of the person, you could put init with address. In our case, we only have one property, so we'll say init with name, right? Okay, so we have our return type, which is just an instance of the type. We have our function name, and now we will go ahead and colon, and we will say the name is a NS string, again, pointer, and the parameter name is name. I could call this anything, right? But it's name here. Okay, so don't feel intimidated by this. That's fine. If you have to go back to your notes, this is not, you're not getting quizzed on this. It's a lot more code, weird code sometimes we have here, but this is what we have. We have our instance, because again, this is creating an instance for us. Instance type, we have our initializer name. We could call this anything, but convention, you want to start with init, right? I don't want to start by saying something like you don't want to go outside of convention, right? Like create, person, right? Somebody's gonna be like, it's just like an instance method. Like, what is this supposed to do? But you want to create your initializers with like init, start off with init as the prefix, and then whatever the first argument is. You could have many arguments, like I could have other arguments as well, or parameters. I could have multiple parameters. Here I have one parameter, name. So let's go ahead and implement this init with name. Any questions about this syntax before we jump into the implementation file?
So can instance type also be seen as like the self from
Yes.
Swift? Okay.
Yes. If we'll see we'll explicitly see self being used in the implementation file.
Okay.
Very good. So let's go to it now. So let's go to the .m, and we will go about here, and we will say initializers here. And if I type in init, it should come up. Init with name. This is ours. So now let's go and see what the syntax looks like. Again, the syntax I'm about to write here is convention. This is what you want to do every time you create an initializer. You want to say if I get back from my super, so everything, this person inherits from NS object. I want to call my super init. So if I was able to get back an object, I could go ahead and set up my initializers or set up my my properties. So the syntax is self, what I get back. What's after the equal sign here is a function call. I'm gonna call super, right? Initializer. I'll call my super init, right? And then at the end, I'll return self. Some of that code is familiar somewhat to what we do in like Firebase when we return self, if everything is formatted correctly and if we get all our properties. But here in Objective-C, what you do, oh my colon, what you do is you first call super. Again, very similar to when we have our init with coder or whatever in Swift, right? So in Swift, if you have your init with frame, for example, which does some like CG-rect, right? You want to call super first, right? So you call super init. Right? Here, you want to do the same thing. You want to call your super first, very similar to VDidLoad, very similar to all those functions we use in Swift and iOS. You want to call super first. In that case, my initializer, I want to call super. In Swift, you don't see that, right? When you create some sort of initializer, like not init with frame, for example, but if I was to just create some initializer that takes in some name, like you'd say init name string, and then you just set your self.name equal to name, and you're done. But here you gotta explicitly call super so that super does its initializations, and then it returns you this object. And once you get this object back, you could go ahead and set your properties in this block here. In our case, we only have one property. So we'll say self.name equal to name. If you had more properties, you would initialize all of them here. So initialize properties here. Cool. Great. So let us continue. Let me make sure we have no errors. Okay. So let's go use that initializer. We could use that initializer. Let's use it in the main function first. Let's go back to main and create a person object. So person, and we will say open square bracket person, allocate memory for this person. Init, now we have two initializers. We have the default initializer that doesn't take in a name, and we have our initializer we just wrote that takes in a name. It expects a string. So here we'll just put the person's name. In that case, it's Tom. Okay, and now we can just print NSLog. The person's name is Tom.name. Run it, semicolon, run it. And here we have the person's name is Tom. So now we don't have to do what we did earlier, where we said create the object and then on the second line, initialize it with some name. So we could refactor our code in our implementation file here if we wanted to. Here, but I'll leave that for you as a challenge or some sort of practice. Just refactor this. refactor code above to use init with name. Did everybody get the initializers to work properly in the main function?
Can I see the initializer?
Yeah. So we started off in the .h. You have this in the .h? Person.h?
1 second, I was catching up because I was lost for a moment. But
so we have our instance type, function name. Again, initializers are functions. We have our property data type, and we have our property name here. This doesn't have to match that name, by the way, so don't get confused here. Doesn't really matter, but you want to keep it the same as we do in Swift. And then in our main, in our .m, that's where we implemented it here. So in the body, the first thing we do in this whole body here, the first code that gets executed is super init. Super init returns an object for us, which is self. And then once we have that self, we could go ahead and initialize all our properties. And then lastly, just return self to whoever is asking for it. Or that instance, right? So return instance. Instance to caller. How you doing, Eric? Good?
got it. Thank you.
And then you're welcome. And in main, we tested it on line 138. Instead of saying alloc just init like we did before, we're doing init with name and just passing the name right away. And there's more things you could add. You could say init with name and phone number. You could do things like that.
What does the initializer return? It returns a person.
It returns a person, yes. So this is the person we have here on the left side of the equation. And then now we have everything on that person. We could call info on that person. We could actually update our info, talking about that. Because now our info just says this is a person, right? So instead of saying the person's name is all the time, actually, let's do that right now. Let's go to person.m. And in our info here, instead of saying this is a person, let's make it more useful, right? We could say the person's name is, and we'll say this, and we'll say self.name, like that, build, right? So this becomes more useful as opposed to like doing the full log all the time. We just call our function. So update your info and let's test it. So update your info from just saying this is a person to saying the person's name is whatever the person's name is. And we'll be able to print out the person's information easier. That's why we have functions, right? So we don't have to repeat code, unwanted code all the time.
I have a question.
Yeah, go for it.
So in the method file for person, who is super? Is super the parent
In our
of
case,
the...
super is NSObject.
Okay, that makes sense. All right.
Yeah, we inherited from NSObject. So how does this read? Person inherits from NSObject. Anything NSObject has, person has.
Okay. Okay.
Very good. Did everybody update their info before I jump into main? Just acknowledgement. One acknowledgement would be good. Can see video.
Yep.
All right, cool. So let's go refactor this here. Just Tom for now. Instead of saying this, we could do, instead of doing that line all the time, we could say, Tom, what's your information, Tom? And then if we run it, we'll see the person's name is Tom. Great, already so much functional, more functional now, right? And easier to write without to write the person's name is all the time like that. Great, cool. So this was initializers. 1 second, let me see. I think we have 10 more minutes or so, so we should be good. 1 second. Let's do one more thing. I'll be able to have you guys do the challenge. Because right now, at the end of the day, to really make this stick, you'll be able to go do the challenges here. And I think at the end of this lesson, you'll be able to do all the challenges. You'll be able to define a class, X point, that holds some Cartesian point, right? And that does X, Y, Z. You'll be able to do everything here, I think, at the end of this lesson. So to set you up for that, let's talk about multiple parameters, right? So we have init with name here. Let's do, that's fine, actually. Yeah, let's update our initializer to take in more than just a name. What else we're gonna get that person? Actually, let's hold that thought. Let's do that on the inherited object. We'll create a fellow object that inherits from person, and it's gonna have its own initializer, probably that. All right, let's go into inheritance then. Inheritance. So inheritance here, we know what inheritance is. Inheritance is the ability for a subclass to inherit from its parent class. That's what we have been doing in Objective-C here, as far as person inherits from NS object, right? So whatever NS object has, person has. Let's go create new objects. So we'll create a fellow object. So if I tell you to go create a fellow object, what are we creating? What do we need to do?
Like create it in Swift, you mean, or like here?
Objective-C.
In an M file.
Create an M file. So Command N, create a new file. I'll do the header file first, and I'll do the .m after. So let's do the header file. I'll call this object fellow. So fellow. So it's a fellow object. Save. And I also need to create one more file. And as Eric said, I'll create a .m file or Objective-C file, M file, right? I'll name it the same, fellow. And I'll say next and create. So now I have my model ready to use. I have my header, I have my implementation file. In my header file, again, we don't need this right now. I'll take that out. So in our fellow.h, let me actually take those two files above my main. Not like it matters, but just for consistency here. So in my fellow.h, let's go ahead and stub out our interface code. So we'll say interface. What is the class name? My class name would be fellow. It needs a superclass, right? Everything needs some sort of class they inherit from. In our case here, my superclass will be person. So fellow is a person, right? I build, fellow is a person. So angle brackets here is, angle bracket imports are for built-in frameworks. And our quotes here for imports are custom types. You with me? Again?
Yes.
So when we start doing things like UIKit next week, and we say we want to use UIKit, we'll have to do import UIKit. Like that. Okay? .h. Don't forget the .h, or else people are going to start yelling. Cool? I'm not hearing too much audio today. How are we doing? Are we compiling? Are we able to compile?
Yes.
All right, again, sorry for that. This is like a lot of header files and imports that's required. Our fellow.h, we import in person.h because it inherits from person. It needs to know what that person is about. In our fellow.m, we need to always import our fellow.h. That's it. All right, cool. So what do we have? So this is inheritance. Fellow is a person. This is the basics of inheritance, right? Inheritance says that an object inherits from the next object. If you could explain it in the terms, this object is, right? An employee is a person, right? A fellow is a person, right? So it inherits. A computer is not a person. Well, not yet. Ben probably thinks so with his Bitcoin trading. But when you could describe an object as a is a relationship, that's inheritance there. So a fellow is a person, a fellow inherits from a person object. So let's see what that looks like in code. So in my main.m, let's show what inheritance looks like. So here I could create an instance of a fellow object. Who I haven't heard from this morning? Nima, are you here? Can you hear me?
Yes.
How can I create an instance of a fellow object here? I want to create an instance of a fellow object, and I want to use the initializer init with name.
Okay, we'll start with fellow.
Fellow.
Point. Do you do the pointer?
Pointer.
And this is where you would choose a name?
Yeah, oh, yeah. I could choose a name. Yeah. Very good. So I'll say Nima here.
And then you would have to allocate space. So
Before we continue, we have an error. Use of undeclared identifier fellow. How do we fix that error? I'll give you a hint. Fellow needs to know about that object here. It needs to know about the object fellow. How can we let this particular file know about fellow?
don't do today at the top. You have to import.
Very good. So we have to import the header file, right? So here we'll say fellow. Now if we go back down, and now it knows about fellow. It's highlighted now. It's great. So to continue on, what's the next step?
Allocating space.
Okay, so we'll allocate space for it. And we have initializers, right? So init here, again, we have the default initializer, just init without anything, or we have init with name. Thank you very much, Nima. So here, to continue on, I could say init with name and give the fellow Nima here a name. And that's, again, inheritance, because if we look at our header file, it's empty, right? There's no initializer here. And if we look at our implementation file, again, it's empty. There's no initializer here. But how does fellow get this initializer? Because of person, right? It inherits from person, same as in Swift. So here, fellow inherits from person. Person has an initializer called init with name. And now in my M, I could use init with name. Any questions about that?
If are we able to override like the info function on fellow?
Ah, very good. Yes, we can. Yes, we can. We could actually, let's print it out first. Let's do Nima info. And let's run that. And here we have the person's name is Nima, right? So here, your question to go answer it. Did everybody get were able to print out Nima info? Oh, we're going over. We're going a little over here.
Yes.
Cool. All right. Awesome. Sorry, I think we're going a little over. We'll have to stop here. Before we stop, I want to make sure everybody there's no questions before. But yes, Eric, we could override this function, and instead of saying the person's name is Nima, you could say the fellow's name is Nima. So I'll leave that as a challenge.
It's not like a polymorphism or something.
This one is polymorphism, but it's basic inheritance, right? Override init with name, not init with name, override info to print. The fellow's name instead. All right, so we have a bunch of like challenges to do and good stuff to do. So one of them is that, and then the other one is I think we could continue finishing all those. Write a C-style function, we know what that looks like. I haven't put an example here. Write a program that calculates the sum of digits. That one you could have done already from last week. Write a function, C-style again, 2 integers, returns a Boolean. That you could have done last week as well. Question 7, write a class called graphic object with the following properties, Write a class called this that inherits. We did inheritance today, so you should be able to do that. Implement and test the function methods, area and parameter. So that's a nice fun one, right? So do that. I'll do it both in Swift and Objective-C just to, because you also practice in interviewing and all that good stuff. And that's a nice little problem here. And this one, using the rectangle class from earlier, add an initializer method according to the following declaration. So this one I showed you here. So this is multiple parameters, which we're gonna look at. But here you see what multiple parameters look like. So I could init with width and height, right? Does that make sense, everybody?
Yeah.
All right, cool. Thank you. Write a program that calculates the sum of integers, C-style function, define a class xPoint that will hold Cartesian coordinate x and y, where x and y are integers. Define methods to individually set x and y, right? Write an Objective-C. Yeah, so define methods to do that, like set x, set y. But something I'll talk about maybe next week, or just like mention it, is in Objective-C before this, like there was a keyword synthesized. Let me just write it down. There's a keyword synthesized, if I could spell it. There's a keyword at synthesized. Before this keyword at synthesized, you had to write your own setter and accessor methods. So you had to write your own setter and getter methods before at synthesized. But basically what that means is I would have to write a method to set a property or to retrieve a property. But now with at synthesized, that method, that's just done for you automatically. I think that was like the last major update of Objective-C 2.0. But basically this is what at synthesized does. But for here, just write the methods yourself. And create an object called car and just like write some methods on it. And that's it. So you could do all that. So I think we're in a good place to say next week, start looking at iOS, right? Because we know fundamentally, like if I tell you to create me a newsfeed view controller, how many files you need? You need 2 files, right? You need a newsfeed view controller.h and you need a newsfeed view controller.m. So that's what it is. Like if I tell you to create me a car object for whatever app we're creating, you need a car.h and you need a car.m. And if I tell you to create me an instance method on a car, you know what instance method looks like because it looks like this. And you would create it in the .h file like this here. If I tell you to create me an initializer that takes in a car with a color, you know how to do that. You have init with car color, some color, right? So we have all the building blocks I think we need to continue next week into Objective-C app development, if that makes sense.